Hello, good morning. In this session of the electromagnetic theory, I'm going to discuss the transverse nature of electromagnetic wave. In the previous session or the module, we have proved the electric field disturbance and the magnetic field disturbance are propagating just similar to the electromagnetic, just similar to progressive wave. And then we said it is going to be the electromagnetic wave. And thereafter, we have proved the speed of the electromagnetic wave is v is equal to 1 by square root of mu epsilon, or in air or vacuum that's going to be mu naught epsilon naught, found to be 2.9998 10 to the power 8 meter per second, or it's equivalent to 3 into 10 to the power 8 meter per second. And then we observed many properties of the light which is propagating through the medium, like doesn't require medium, very high velocity, the rectilinear propagations. So many properties of the light are going to be same as that of the electromagnetic wave, or the electromagnetic waves, many properties are going to be identical to that of the light waves. Okay, so therefore we concluded why can't be the light is going to be electromagnetic in natures. Okay, so with this we are able to explain many properties of the light, including the so-called interference and the diffractions. So when we are analyzing the polarization property, we found it difficult to assume the light is traveling through the medium in the form of a longitudinal wave. So therefore we wanted to confirm, is it the electromagnetic wave is going to be longitudinal in nature, or the electromagnetic wave is going to be transverse in nature. So that is what we are discussing in today's discussion. It is a purely a mathematical analysis. Okay, in that mathematical analysis we are coming across some conclusions, especially differentiation of something is called zero, that means that something is constant. These ideas we are using it, and then we are going to confirm the so-called the electromagnetic wave are transverse in nature. Okay, so this is the initial background you needed it, or the ideas you needed it when we are discussing the transverse nature. Just go through this. For free space or vacuum, the Maxwell equations are this: del dot E is equal to 0, free space or vacuum. That means there is no charges, free charges. This del dot B is equal to 0, del cross B is equal to minus dou B by dou T, and del cross B is equal to mu naught epsilon dou E by dou T. So here that second term sigma E, that is not there, because we are discussing the free space or a vacuum. In the case of a free space or vacuum, no charges. So here it is rho value 0, and here sigma electrical conductivity is 0. So our Maxwell equation 1, 2, 3, 4 reduces this. Now you take the first Maxwell equation, del dot E. So this you split it. Okay, I dou by dou x, like that. So this is the first, I dou Ex by dou x plus I dou Ey by dou y plus dou Ez by dou. So these are the components. Okay, the first equation in terms of the component, like this. This is the second equation in terms of the component, dou Bx by dou x, the x component, dou By by dou y, the y component, dou Bz by dou z, z component. And this is exactly same way the third equations. So we have written this side it is a curl of a vector, and this side dou B by dou T. X component you just write dx, y component dy, z component. What it says? The rate of change of magnetic field with respect to time induces an electric field, or magnetic field variation at a point produces the electric field. So that is what we are discussing. Dou Ez by dou y minus dou E by, this is the first component, dou Ex by dou z minus dou Ez by dou x. This is the second component. Similarly, dou E by dou x, dou Ex by dou y equal to minus dou Bz by dou z. This is the third component. Okay. So first equation in terms of component, second equation, and this is the third equation. Similarly, the fourth equation in terms of the components. So the component is how we written I j k dou by dou x dou by dou y dou by dou z, and then bx by bz or ex ey ez. In that way we have written this one. Okay. Now the 1, 2, 3 equations are written in their components. Now this is the assumption we make it. Let us assume plane electromagnetic wave traveling in the direction of the x-axis. We assume it. So what direction the wave is traveling? Along the x-axis. What is the meaning of this? That means the E and B, what are electric and magnetic fields, are not the function of y and z axis. If a wave is traveling in along x-axis, E and B are not function of y and z. Suppose the wave is traveling along y-axis, E and B are electric and magnetic field are not the function of x and z. If the wave is traveling along z-axis, the electric and magnetic fields are not the function of x and y. So that is taken into consideration. Again, carefully go through it. Plane wave is traveling in the direction of x-axis. So what happens? Exclude x. Electric field and magnetic field not the function of y and z. That means dou by dou y, dou by dou z are not existing. So this and this cancels. This and this cancels in first equation component and the second Maxwell equation component. Second and third term going to be 0. So if the second and terms are going to be 0, what is left? Dou Ex by dou x equal to 0, dou Bx by dou x equal to 0. What is the meaning here? Differentiation of something 0, then that something, in the first case Ex, in the second case Bx, something is constant. What is the meaning? Electric intensity value along the x direction constant, not varies or fixed. Clear? Or similarly, Bx constant, magnetic field strength value along the x-axis. Here the direction in which the plane wave is traveling is constant, not varying. Understood? So from the first and second equation we got, if the wave is traveling along the x direction, the Ex electric intensity value along the x direction constant, Bx the magnetic intensity value along the x direction constant, or they are not varying. See, this is important. Electric field variation produces magnetic field. Magnetic field variation produces electric field. What we concluded just now, x direction, the electric field intensity and magnetic field intensity not varying. Then wave is propagating. How? If they are not waving, there is no chance of the production of the electric field to magnetic field to electric field. If they varies, then only electric field produces magnetic and magnetic field produces electric. What we said, electromagnetic wave travels along the x-axis. That means the electric intensity or the magnetic field intensity along the x-axis only. But remember what here it confirms, the electric intensity value is not constant. Electric intensity value is constant along the direction of propagation, x-axis. So magnetic field value is constant along the direction of propagation, x-axis. That means Ex and Bx are not varying in the direction of propagation. So if Ex and Bx are not varying in the direction of propagation, naturally the electromagnetic wave propagates, means the electric field and magnetic field should vary in a direction perpendicular to the direction of propagation. In a direction perpendicular to direction of propagation, which is that here x-axis is the direction of propagation, perpendicular means y and z. Okay, so that is what the first step of confirming the electromagnetic transverse in nature. Here what we said is just the field in the x direction does not vary or remains constant. Okay, but electromagnetic wave propagating means naturally there is a variation of electric field or the variation of magnetic field which is not taking place along the x-axis. That means it should take place in a direction perpendicular to x, that means y and the z direction. So this can be confirmed again by this particular equation. Same, if the wave is traveling along the x-axis, the component of the electric field is the not function of y and z. Therefore, this first term and this term going to be 0. Dou by dou y of Ez, dou by dou z of Ey, this is going to be 0. What is less? Dou bx by dou t equal to 0 or dou bx by dou t equal to 0. Similarly, this term is 0, second part, and dou by dou z here and dou by dou y here, these two terms 0. What is left is dou Ez by dou x equal to dou by dou t, and then in this place dou Ey by dou x equal to minus dou b by dou z. Now carefully observe this. Here magnetic field strength dou bx by dou t equal to 0. Okay, so this is the variation of the field with respect to time. In the previous, it is a variation of the field with respect to space. Okay, so both says the x component of the electric field and the magnetic field with respect to space variation or with respect to time variation, it is not changing. So that was a confirm. The field is not changing, electric field or magnetic field strength in the direction of propagation not changing with reference to space or with reference to time. So therefore, there is no question of the longitudinal category of the electric and the magnetic field waves. So not here only, just look at the second equation, dou Ez by dou x, the variation of electric field, space variation of electric field in the z direction will make the time variation of magnetic field in the y direction. Look at that. Space variation of electric field in the z produces the time variation of magnetic field in the y or vice versa. Look at in this case, the space variation of electric field in the y direction produces the time variation of magnetic field in the z direction. And just observe this equation and compare here. The minus sign indicate it is the magnetic field direction is reversed. So here it is y and it is z, and in this case it's z and here it is y. Okay, and again the same result we can observe in the next one. So look at this, dou by dou y, dou by z, not the functions. So fourth equation gives me dou Ex by dou t equal to 0. What is this? Ex component of the electric field along the direction of the propagation with respect to time is constant. Okay. Then first term 0 here and here the second term 0. What is left? Dou bz by dou x equal to dou ey by dou t, and compare with the previous. It is just reverse, dou ez by dou x equal to minus dou by by dou t. Okay, what is the space variation of the z component yield the time variation of the y component and the vice versa. Look at in this case it is a minus here, whereas in this case both. Again the space variation of the magnetic field produces the time variation of the electric field. So what these four terms says, first, second, dou Ex by dou x equal to 0, dou Bx by dou x 0, And the third and fourth equation, first part says dou Bx by dou t equal to 0, dou Ex by dou t 0. That says the component of the electric field in the or the magnetic field in the direction of the propagation with reference to space or with reference to time is constant, no variation. That confirms the electromagnetic wave is propagating because of the variation of the electric and magnetic field that does not happen in the direction of the propagation. That means indirectly it will happen in a direction exactly perpendicular to direction of propagation, that will be in the y and z. So that's we observed with the help of a equation 3 second component, equation 3 third component, and similarly equation 4 second component and equation 4 third component. And in that the one very reversal of the direction is also observed. Look at minus dou bz by dou x, and here it is dou ey by dou t, and in the previous case it is dou ey by dou x is minus dou b by dou z. So this is what the reversal of the directions. Okay. So in general you can conclude this: the electromagnetic wave are produced only by means of the change in the fields. That is the first. Z component of del cross E is associated with the Y component of the B, and the reverse of this, look at Y component of the del cross E is associated with Z component of the B. So this is we observed in the fourth third component of the equation 3 and the second component of equation 4. So variation we observed, and then E and B do not vary with the space or time along the direction of the propagation. Here the direction of propagation we restricted to x. Therefore Ex and Bx does not vary with respect to space xyz or with respect to time. This is the conclusion. There is no component of electric and magnetic field along the direction of the propagation. That means E cross B is always perpendicular to direction of propagation. What is that? E is light is electromagnetic wave is traveling along the x direction. So there is a component along the direction which is perpendicular to direction of propagation, that should be y and z. That means the electric and field component, if it is varying, that will be in the y and z direction. That's what E cross B are perpendicular to each other. So these four concludes the light is electromagnetic wave is transverse in nature. So the difficult argument comes here. The fourth equation, the fourth Maxwell equation, second term, and the third Maxwell equation, the third term, where there is a negative that indicates the reversal of the electric and the magnetic fields. So in general, you take a particular direction. In that direction, with reference to space or time, the electric or magnetic fields are not varying. Now put a question, then how the electromagnetic wave is propagating or where the variation is observed. It is observed in a direction perpendicular to direction of propagation. That if wave is traveling along the x, the perpendicular means y and z direction. So that those components are not going to be zero. You can see in the Maxwell's third equations, the second and third component, and the Maxwell fourth equation, second and third component, that is not going to be zero. That confirms there is a component of the electric and magnetic field in the remaining two direction when compared to the direction of propagation. Here x-axis is the direction of propagation, remaining two means the y and z. So that confirms variation of the electric and magnetic field if it happens when the electromagnetic wave traveling, it is always perpendicular to direction of propagation, or in short the light, the electromagnetic wave is transverse in nature. Okay, thank you. So this is the rate of flow of the electrical energy, the Poynting vector that indicates the how much amount of energy is crossing in a direction exactly perpendicular to direction of the propagation of the light energy. So that is expressed in terms of a vector P is equal to E cross H or this, and in that the amount of the energy per unit volume, or the energy density due to the electric field is this much term and due to the magnetic field is going to be this much term. So this is what we are indicating, the amount of energy transported perpendicular to direction of propagations. Okay, thank you. Thank you.